Okay? So on this one here, if you were to do a linear function, you could graph it like you normally graph a line. Since you see it's a line and know it's a line, if you just want to do y equals mx plus b, that one you don't always have to have a parent graph. But if you want to describe what happens, sometimes it helps if you drew the parent graph. If that makes sense? So you know your original parent graph is just, again, to the corners on your paper, kitty corner on each square. That's the parent graph, and then if I graph the new one, I'm going to have to decide, is this on the outside or the inside? And again, since there's no grouping symbols, this negative is on the outside. So the outside is the y values, and it's the same operation as what's happening to it. Okay, and the y is the up and down. So, and it's a -1 here, being multiplied, so we're going to do the same thing. We're going to multiply by -1 to every y value. So this y value is at 0. We're going to multiply by -1, still get 0. This one is at 1. We're going to multiply by -1, and now that y value, which was here, is now going to reflect and go down here. Okay, and this y value is at -1 right now. -1 times the -1 here gives me a +1, so then that reflects up in that direction. So now, if you can see, our new line, I got a little wavy, is now that blue line, which has a negative slope. Okay, and it reflected. So everything down here reflects up, everything here reflects down. So I'm going to describe the reflection. It reflects over the x-axis. Okay? Alright. So the third thing, or type of translation that we can have, is a dilation. And what a dilation does is it changes the height. So it'll get steeper or flatter depending on what is showing. So, and this equation says, and they also talked about if my coefficient or the number in front of my x is bigger than 1, it's going to get steeper or bigger. If it's less than 1, like a half, then my slope is like up 1/2, which means, or whatever it is, whatever fraction, it gets less steep compared to the parent graph. Okay, so on this equation it says describe the dilation and then graph the function. So my equation, if you can't see it, is y equals 4x. So therefore I would graph my original function, which they did here. So there's my original, up 1/1. Okay, and then I want to change my height or whatever's happening to it. So again, I can use the same chart that I always use. So the question is this 4 on the outside or the inside? Okay, and it's on the outside again. If you want it on the inside, it has to have parentheses or grouping symbols. Then it would be on the inside, but this does not. So therefore it's on the outside. Outside my y values change, which are my ups and downs. Okay, and it's the same operation of what's happening. So what operation is happening between the 4 and the x that I do not see? Multiplication, correct. Okay, so I'm going to multiply by 4. And once I've done multiplying by 4, I'll get my new graph. So if I take each point here, so let's go to here. Okay, that's at 0. So 0 times 4 for my y values would still be 0. The height here is at 1 to start, but 1 times 4 would be 4. So then I would count from the 4. And now again, when I say 4, you don't count 4 up from this point, because you're not shifting it up. It's 4 is my new y value. So if that's 1, then I count up on the x or the y-axis, 1, 2, 3, 4. So then it's actually only 3 up from that point, but it's 4 up from the original point, if that makes sense. It's always based on your graph. Okay? If you want to do this one, the new height, which the first one's at 2 here, well, 2 times 4 would be 8. So then now it's going to bounce up to 8 on that one, which you can see that would connect and go through there. Okay? And that would be my new parent graph. And again, if you know how to graph the line y equals 4x, start at 0, slope is up 4/1. Okay, you could do it that way too. So linear functions, you can do it, just draw the line. But other ones, it's probably easier to graph the parent graph and then move on from there. And then it says here to describe the dilation. You would say it's got 4 times taller. So that line, or steeper. Okay, so you can say you got 4 times steeper from the parent graph as well. Alright. On your paper, I would like you guys to try 4a. Okay, remember, draw the parent graph. So again, x squared. You guys already did one and I did a couple with you. Draw it perfectly on your graph first and then determine what's happening after that. So I'll give you a little bit of time to try 4a. Again, you have to draw each one of those points separately when you guys are doing those parabolas, because we got to make sure they're on the right graph. You're not just making a random swoop on your graph and calling it good. Okay, so mark those points properly. And again, how do I get all those points? I just do the normal x squared. So 0 times 0 is 0. 1 times 1 is 1, so over 1 up 1. 2 times 2 is 4, over 2 up 4. And then the same with the negative, so like a negative 3 times a negative 3 is a positive 9 on that left side there. Okay? So again, the question is, where is the 2 located? Okay, and that would be on the outside. So on the outside it's the y values and it's the same operation. Y's are my up and down. So it's going to be going up and down here. Something's going to be moving up and down. And the same operation. So what operation is happening between the 2 and the x squared that we do not see? So between the 2 and the x squared, it is being multiplied. So the opposite of multiplication, sorry, not opposite, the same thing as multiplication is we're going to multiply by 2 to every y value. So 0 times 2 is 0, so it doesn't move. Here the y value is 1, so 1 times 2, what's going to happen to that guy? 1 times 2? Well, 1 times 2 is 2, so now that's going to move up. Let's ungroup that here. So 1 times 2, that will be moving up to 2. Okay, this spot here is at 4. 4 times 2, what is that answer? 8, so that reflects up to here. And again here are my other points I'm going to reflect. So 1 would reflect to 2, or not reflect, it would be dilate. So 1 times 2 is 2, 4 times 2 is 8. So that would come up there. And if you do the other one, here 9 So 9 times 2 is 18, which goes off my graph. You don't have to mark it, and then the other side is the same. So on this one, if you look, okay, since it was on the outside, it's going up and down. How I describe it, it was 2 times or twice as tall or steep. Okay, so it became 2 times as tall or 2 times as steep. Twice as tall. Okay, I want you guys to try 4B now. So again, on 4B, you are going to draw the parent graph. So instantly you guys should be able to look at 4B and determine what shape that is. So on your paper right now, draw that parent graph. And then once you draw the parent graph, figure out if it's on the outside or the inside and what values are changing. And then determine if it's the same operation of what's happening on the inside or if you do the opposite operation. So that's on the inside. I don't know if we've done the inside one yet. The x value is changing, which means it's going to be going from left to right. So it's either left or right. The heights will not change. And it's the opposite operation. So let's first figure out what's happening inside there. So it's 1/3 times x. So what's the opposite of timesing by a third? It'd be dividing by a third. Okay, can we divide by a fraction? Nope. So instead of dividing by 1/3, we do the opposite, or not the opposite. Dividing by 1/3 is the same as multiplying by the reciprocal, correct? So we're actually going to multiply by 3. Okay, I'll use the multiplication sign of a dot instead of an x. Okay, so we're going to multiply by, actually, that's kind of confusing too. Let's just say we're going to multiply by 3. Okay, so the opposite of multiplying by a third, or dividing it into 3 parts, is multiplying it into 3 parts. Okay? So we're going to multiply by 3 will be the operation that we're going to do to all x values. Okay? Which means everything's going to be moving left to right. So let's figure out my coordinates here. Okay, so 1, -1, 2, -2. Okay, so what is the x value of that coordinate? The origin would be 0. 0 times 3 would still be 0. Okay, so the next one here that'll change now. So what is my x value there? It'd be 1. So what's 1 times 3 going to give me? 3. So now this point is now going to shift, or not shift, but multiply 3 times out to there. Okay, what's this x coordinate? -1. So what's -1 times 3 going to give me? and that would give me a -3. So now that's going to bounce out to there. So again, once you know where that point is, we know it's a sloped line, so it's the same slope all the way out. So it's, you could actually draw it out, but because you know the slope is up 1, and then to the right 3, or rise 1, run 3. You could do the same slope again, get to the next point, and so forth. And then if you go in the other direction, it's rise 1, and then to the left 3. So now that, you can just keep doing it that way too. Okay? So now if I describe the dilation, I would say it was stretched horizontally. There's 2 L's. I might be wrong on that. Stretch horizontally by 3. Or it's 3 times as wide. It would be another way of saying it. So the V just got 3 times as wide. Okay, and it's on the x-axis, so that's why it's stretched horizontally. Versus on the y-axis, which like this parabola, this was stretched vertically. 4A was vertically stretched, 4B is horizontally stretched. Okay? Alright, I think we will do this one, and then we might be getting close to time here. So I'll do this example, and then this might be our last one for today. Oops, sorry. I'm just going to actually get rid of this, and I'm going to do it without the example here. Okay, so it says here, Ethan is going to add brick walkway around the perimeter of his vegetable garden. Okay, the area of the walkway can be represented by this equation. So y equals 4 and then x plus 2.5 squared minus 25. Okay, describe the transformation in this function and then graph the function. Okay? So, actually we'll have time to do that last one, I think, because I'll explain it here and I'll give you a little bit of time. So, we got to determine what are my numbers, so how many numbers are up there. I got 3 numbers that are important. Okay, here's one number, here's another number, and here's my third number. Okay, and this number is important to know what the parent graph looks like. So what shape is that going to make? And it is going to make a parabola. Okay? So it's going to make a parabola, which then again you draw your parabola. But on this one, I'm just going to do a rough sketch because we just kind of off the graph a little bit when we do it. So that'd be my original parent graph. Okay? I think the first thing I want to do is, so that it's easy, is I'm going to do this 4, which is going to change this, is on the inside or the outside? 4 is on the outside, so that's going to change the y value. Okay, and it's being multiplied, so we're going to do the same operation. So every y value or the height is going to be multiplied by 4. Okay, so pretty much this was at 1, 1, it's now multiplied by 4. So now it's 4 here. This was at 4, multiplied by 4 is 16. So this thing got super steep. Okay, so I did the 4, and that one's done. Okay, once I got my super steep line, now I can do my shifting, because I have pluses and minuses. Those are the easy parts, I think. Okay, so right now, I'll do this part here first. And it doesn't matter which one you do first, honestly, you can do any of them, but the multiplying the height is probably the easiest to figure out what it would turn into first before you shift it. 2.5 is on the inside, so on the inside I change my x's, which means I'm going to do the opposite. Okay, so on the inside we're going to do the opposite. And it's left and right, it's the x values. So instead of a plus on the inside, the opposite of that would be a minus. So all x values are going to shift to the left 2.5. So then I move to there. Shifting my parent graph, and then here I have a negative 25 on the outside, so again, the outside it's the y values, up and down. Okay, so up and down, and we do the same operation as what's happening. So on this problem here, since it's a minus, same operation, still be minus, so I'm going to minus 25, which means it would drop all the way down to here. So it pretty much started here, it got 4 times as steep, it shifted left 2.5, and then it went down 25 units. And that would be my new parent graph. Oh yeah, okay. So that dotted line is not the answer, it'd be the solid line here on the graph. Okay, what the heck's going on? But yep. So that solid line would be what it would look like. Super steep. And their graphs are kind of stretched out pretty good. But again, however you number your graph, that's kind of how your graph's going to look too. So, okay, I'm going to have you see if there's enough time here. I'm going to have everybody try this last problem, and then we will give you the answer. Now, instead of me waiting here, I'm just going to start it, but pause it. So whoever's subbing, please pause it, and then let them try it, and then you can go once, maybe when it gets close to the bell. Alright, so here's my function. I think it says 5/9 x minus 32 can be determined in temperature of Celsius to Fahrenheit. Okay, and then describe the transformations of the function and then graph the function. So, my original parent graph, since there's no so it'd be y equals that. There's no squares, there's no absolute values, so it makes the original line or linear function. Okay? So then after my original function, there's 2 things happening. The first thing I'm going to deal with is the 5/9. So if 5/9 is on the outside, it's the y values and it's the same operation. Okay, and if it's on the inside, it is the opposite, but this is on the outside. Okay, so every y value is going to be multiplied by 5/9. Okay, so if you think about it, 1 is the y value here. 1 times 5/9. Is that going to get steeper or not? Less steep. And 5/9 is less than 1, so it's actually going to get less steep. 4.5 is like half of 9, so it's like a little bit below half, or a little above half, sorry. Okay, so the number I would use here, which is a little tricky, is I would do 9. Okay, so what's 5/9 times 9? And that would be 5. So at 9, this point would drop down to here. Okay, so then you're going to have a line that looks like this. Okay, so then it gets less steep, and then this negative 32 is on the inside, and on the inside it's the x values that change, and it's the opposite. So instead of opposite of this guy, opposite of negative would be a positive. So it's going to, and it's going to, again, it's on the inside, it's the x's, and it's the opposite. X's go left and right. So opposite of negative would be positive, which would be to the right, 32 units. So then this whole graph, which is again hard to draw, will go over 32 units, and it's the same 5/9 slope. Okay? So it says describe the transformation of the functions, then graph it. It got 5/9 less steep. Okay? And it was right 32. And that would be the description you would use. Okay, I'm guessing you probably didn't get to this problem today, so we will do it tomorrow when I get back. Alright? Thank you.